Hi guys, my name is Robert Feranek, I'm from Fedevel Academy, and in this video we are going to speak about differences in defining differential pairs in the old Altium Designer and in the new Altium Designer. Differential pairs are the signals which need to be routed together, and the difference in the old Altium, this is the old Altium, and in the new Altium, this is the new Altium, is mostly in the rule definition. In the old Altium, if you go to design rules, then you can see to specify differential pair, you would have to create three different rules. You would have to create a rule which specifies the width, track width of the differential pairs. Here you would need to specify the gap, the distance between the tracks, differential pair tracks, and you would have to specify the tolerance, what is the maximum difference between the two differential pair tracks, between the plus and minus, between the positive and negative signal. In the new Altium Designer, when we have a look on the rules, you can see you specify only two rules. This one here, and in this one rule you specify the gap and you also specify the width. So basically they moved this width definition to this one rule. It's all together here now. And then you also specify the difference between the plus and minus, positive and negative signals. To make a proper video where you can see how to specify differential pair signals in old Altium and in the new Altium, I'm going to show you how to do it in both Altiums. Very quickly. It's very similar. First, you need to tell Altium Designer which signal is going to be negative and which one is going to be positive. So add _n on the end of net name for negative signal and add _p for the net name or behind the net name of the signal which is going to be positive signal of differential pair. Then go to place, directives, and use this differential pair directive to tell Altium Designer this signal is a differential pair signal. What I also do, I add a parameter called class name, and we will, for example, use something like diff90. When we add this parameter, we will automatically also create a group of signals, group of all the differential pair signals which need to be routed by 90 ohm impedance. I will show you then. And I would like to see it here, so I will make it visible. I will move it here. We need to add same directive also to these other signals. So I press Ctrl+C, Ctrl+V. I will copy this class name, Ctrl+C, because I'm going to make it also in the new Altium Designer. So go with me. Place, directives, differential pair, add class name diff90, make it visible. Okay, I'll move it here, Ctrl+C, Ctrl+V. Now I'm going to PCB and I'm going to show you there are no USB differential pairs specified yet. So I go to PCB, select differential pair editor, all differential pairs, I order the differential pairs by name, and you can see here is no USB 0. It is exactly same here. Differential pairs editor, all differential pairs, order it by name. There is no USB 0. Now we are going to import the changes what we made to the PCB. Go to Design, Update PCB document. I also will do it here because it takes a little bit time. So Design, Update PCB document. Now we will do two things. One thing will be we will create the USB 0 differential pair, and we will also create the net class, which I was talking about. I will show you where the net class is. So execute the changes. Close. Also in the old one, execute the changes and close. Now when I go to the PCB, when I go to nets, then here you can see this is the net class what we created, differential diff90. And you can see here is the USB 0 and USB 0P. If you need to create, or if you have more differential 90 ohm differential pairs in your design, you can put all of them into this class like this one, and then you will see all the signals which need to be routed by differential pair 100 ohms or differential pair 90 ohms. But be careful, this is net class. Then I will show you how to create differential pair class. Differential pair class is different from net class, but we will use exactly the same name. And that's the next thing what we have to do. We need to create a net class. Net class will be placed here in the differential pair editors. We need to create net class diff90. I go also here. We need to create a differential pair net class diff90. To do it, it's very simple. Go to Design, Classes. Here are the net classes. We don't want net class. We would like to create differential pair class. So right click, add class, right click, rename the class. Let's call it diff90, and we would like to add the USB 0. See, here is the USB 0. Now I'm going to show you. If we click on the all differential pairs, here is the USB 0 now, which we created from the schematic. And we also created this differential pair 90 ohm class with USB 0 in it. I will do exactly the same here. So Design, Classes, differential pair class, right click, add class diff90, and we will add what? The USB 0. Okay. So we have differential pair class called diff90. At this moment there is only USB 0, but later we would like to add there also USB 1 signal and maybe PCI Express and all the signals with 90 ohm differential pair impedance. And what we have to do, we have to set up the rules for this differential pair class. And in the rule, we will specify the track width and the gap on every layer of our PCB. To specify rules for differential pair signals, you will need to have a stack up, and you will need to know the exact parameters on every layer for 90 ohm impedance. And we will put these numbers into the Altium Designer. Let's do it. Select diff90 differential pair class and click Rule Wizard. Let's call it diff90. Specify the track width and on every layer. By default I will put here like 0.1, 0.1, 0.1. I will make it a little bit bigger if it's possible. No, it's not really possible. And from this we can see for 90 ohms the track width is like 0.101 on top and bottom layer. I'll put it here on every tree and also on the bottom layer. I will order it by layers and I'll put it here. Okay, now we need to check layer 3, 90 ohms on layer 3 we need 0.085, 0.085, and also layer 10. Perfect. Next, we would like to have the difference between the plus and minus signals maximum 5 mils. So I put here 5 mils and leave only this one. Check nets within differential pairs, so check the plus and minus signals. And now we need to specify the gap between the tracks. Again, I will put here by default 0.1 millimeter. This one I put initially 0 because we would like to see where all the uncoupled length is located. Uncoupled length, it means when the tracks cannot be routed within the tolerance. So for example, if there is no gap 0.1 millimeter but 0.2 millimeter, Altium can show you these parts of the tracks. Later you can increase it to like 50 or 10 millimeters when you are happy with, when you check all the places where this uncoupled length is located. And we need to change, or we need to set the gap for every layer. Let's have a look here. On top and bottom layer, the gap is 0.114. 0.114. Again, I will order it by layer name. And we will check 90 ohm, layer 3, 0.115. Also same for layer 10. Oops. Good. Next. Finish. Now you will see it created 3 different rules. Go to Design, Rules, and you can see it created this one with the track width for each layer. It created this one again with the gap for each layer, and also we created this rule where we specify the maximum difference between plus and minus. It is almost exactly same for the new Altium. Select the differential pair class called diff90, then click to rule wizard, next call it diff90, next the tolerance between plus and minus 5 mils, and here you can see all the rules are in this one table, all the rules for the track width and also for the gap. So I'll set it up to 0.1 by default for everything. I will put here, no, I will put here 0 millimeters. Before I said 50 millimeters, I meant 5 millimeters or 10 millimeters. Okay, so 0, and once you are happy with the uncoupled length, change it to 5 millimeters or 10 millimeters, whatever is the maximum uncoupled length in your design. But it should not be 50 millimeters, that's too big uncoupled length. It should be as low as possible, 10-15 millimeters maybe. And let's put the numbers here. I will order the layers. I'm going to check the stack up. So track width for the top and bottom layer. They improve it. Can you see it's not jumping between different numbers? It's now nicer than it used to be in the old Altium. Let's have a look on the gap. Gap. If you have problems when you route the signals and you need to adjust this minimum width or minimum gap, you can do that. But normally, if you use all the three numbers exactly the same, it should be just fine. In the old Altium Designer, you would need to adjust it, especially in the corners. But in the new Altium, it somehow accept also the corners. You can keep all the three numbers exactly the same. Let's put there the numbers inside the PCB. Width. Oops. I'll put it back. My mistake. I need to go on layer 3 and copy it again, and layer 3 width. Okay. Layer 10. Oh, it's jumping again. Okay. Now the gap, almost done. Perfect. Next, finish. When we have a look, design rules, you can see it created only 2 rules. This one with all the information about the track width and the gap, and this one with information about the tolerance between plus and minus. So that's the biggest difference between new and old Altium. And when you import old Altium Designer design to the new one, you need to adjust, you need to create these new rules. Now let's check if we set up the rules correctly. I click on the diff90, I select the USB 0, the signal is here. When we use this button, this interactively route differential pair connections, the Altium, based on the rules which we set up, will exactly use the correct track width and the correct gap for this layer 3. So let's try it. We are going to measure it, okay? It's layer 3, so the track width for layer 3 should be 0.085. I double click and the track width is 0.085. Good. And the gap should be 0.115. I'm going to measure the gap. Now be careful, a lot of people send me a message how to measure the gap between the differential pair signals. You have to use these measure primitives. Measure primitives will measure the gap between the signals. If you use measure distance, it will measure between middle of the tracks. So use this, measure primitives, and select like this and this, and it says 0.115. That's correct. Let's have a look on the old one. So USB 0 on the new one. This is the new Altium. Use the same command. Double click. The width is 0.085, which is correct. And when we measure the gap, it says 0.115. Perfect. So there is not really much difference between the old Altium differential pair settings and the new one, but there are some you need to know about them. I hope you found it useful. Thank you very much for watching, and see you in the next video. Bye.